Cool. So I'm trying to get some clickbait out of you. So out of all those languages.
So
So
yeah, I mean,
you
okay,
kind
so
of said that OCaml is kind of like not your favorite. You kind of got into it. It's fine, but it's not your favorite, right?
it's yeah. I would say that I was very disappointed with OCaml because I had kind of heard like there are people on Twitter that are very excited about OCaml,
Mm-hmm.
and they don't fail to tell you that they're excited about OCaml whenever you say anything about other functional programming languages. And so I had really hoped that there's something there, but the library ecosystem is so abysmal, and there's that it's basically impossible for me anyway, to write real world software in there. It's um, yeah, I don't know.
So it's
It's
more of the library thing than our ecosystem thing than the language itself, or
I mean, the language is also it's just so the language also is. I mean, it's kind of hard to tell these two things apart
mm-hmm.
because a language without its ecosystem is very very little essentially. So the problem with OCaml, or like so as a language, I think OCaml is fine. The fact that you don't have any ad hoc polymorphism is really annoying. So you have to mess around with modules and functors and that kind of stuff,
Mm-hmm.
which is not as elegant a programming language as I'd hoped. The module language is like a separate language, and it's kind of
Okay.
weird. But really, the biggest problem is the library ecosystem, or the fact that there's none. So it's when you write stuff in PureScript and you need something there's no PureScript library for, well, you just look up the npm, the node library, and then you write a couple bindings for the few things you need, and then you're good. But
Mm-hmm.
in Camel, that doesn't work. So,
Okay. Yeah, that makes sense. Okay, that's interesting.
and I mean, the other problem, or like the biggest problem that I have now, because I'm trying to build a network thing in OCaml,
Mm-hmm.
and well, it's single threaded and there's no event loop. So it's actually everything you do is blocking essentially. And you have to pull in an event loop as a library, but there's two of those that are widely
Okay.
used. And so one half of the libraries now sometimes works with one and sometimes works with the other, or it's just a purely synchronous library. And then,
Okay.
so,
Yeah, that
so
sounds like rough. Okay, so we are removing OCaml for the favorite language
yes.
list. So, but I guess like that's probably not too hard to guess that probably PureScript is your favorite language, or is it not?
Oh yeah, as a program language, PureScript is
Mm-hmm.
my favorite language. Absolutely, yes. I do have to say that I really enjoy Rust.
Okay.
And that's partially, again, the library ecosystem is fantastic. The libraries are super well written, well documented. There's a very genuine kindness in the community for some
Mm-hmm.
in some sense. Like everything is done with empathy and compassion, or it feels like that. Where it's just
Cool. Yeah, I've heard a lot of great things, and I'm kind of planning to get into Rust myself at
Mhm.
some point. Probably sometimes on stream, because that's the only time I get to do this sort of thing. So I might do a learning Rust series or something at some point.
If I can give you one tip
Mm-hmm.
that as a Haskeller that
Oh yeah,
gets into
please do.
Rust, it's that Rust is not Haskell. It's not even Haskell in that, like, it's not even close. You end up being, if you try to write Rust as you'd write Haskell, you end up writing clone a whole lot, and you will find out that lambdas in Rust are not like lambdas in Haskell.
Cool. Okay, I'll keep that in mind.
Mm-hmm.
Um, okay, so let's see. A couple of people are still commenting on, like, piling on OCaml here. So Vince is saying that the best thing about OCaml is Beam and that the dogs are really poop, quote unquote.
Wait, Ocala's Beam? What's Beam?
Yeah, but
I don't
then,
even
like,
know.
I'm not sure what you mean by Beam,
I mean,
because
the Beam is Erlang,
yeah,
but
exactly.
maybe
So
there's a
maybe
library
there's
for it or
something
something.
else there. So a bigger problem with OCaml is how slowly it's evolving. They've been working on multi-core algebraic effects and modular implicits forever. Okay.
Well,
Yeah.
there actually multicore is actually now picking up steam again.
Mhm.
It's probably going to happen soon-ish. Module implicits are not going to happen anytime soon.
Yeah, I have no idea. I'm not following the OCaml at all.
Yeah.
I don't know pretty much anything about it. So
Mhm.
Palu asked a while ago, what about the Motoku language?
Yes, so that's the language I'm working on now
Oh,
at
so
work.
okay. So at work, you're building this language. So you said that you're
Exactly.
building a compiler with OCaml, and this is the language that you're building a compiler for.
That's the
Uh,
language we're building a compiler for. Exactly. Yes.
okay. Do you want to tell us something about it right now, or
Well, I mean, I can tell you something about Motoku. There's a few things that are interesting about Motoku.
okay? So what kind of language is it?
So Motoku is a. So I'd say it's. Well, it's not really a functional language. It's kind of an ML in a sense, ML-ish language. So
Okay.
it does have first class functions, and you can do all kinds of higher order programming with functions. It does not have the defining feature really about Motoku is that it's structurally typed through and through. So
Okay.
you could probably compare it to TypeScript, but without any and with um, and with lots more uh, and the subtyping relation is more interesting essentially. So it has first class polymorphic variants,
Okay.
or like it doesn't have polymorphic variants. They're variants, they're variant types.
Mm-hmm.
Um, um, and the main way of doing polymorphic things is through subtyping and not unification like in PureScript.
Okay.
But it's a structurally typed language through and through, which is motivated by the fact that it's supposed to be used on the intercomputer, which is the system we're building, essentially like a new cloud kind of thing.
Okay.
And because it's a distributed setting, the language designer Andreas Rosbach, who has also basically designed lots and lots, like a large part of what WebAssembly is today, says that nominal typing doesn't work in a distributed setting because you have no clue at what version someone is, and so a name doesn't mean anything in a distributed setting because you don't know who has who owns that name, who can say the truth about a given name, right? So it
Okay.
has to be structural all the way through.
Interesting.
And it's an actor-based programming language because again, that's the model of concurrency we chose for the distributed setting. And then it has a few features that make it work with the platform we're building. So it has there's some we've got async await because again it's a distributed thing. You kind of have concurrency going on, and it's a language that compiles to WebAssembly, which is
So
there's very
does
few
that work
languages
at
that compile.
does that work at the actor level, the concurrency? Like each actor can do multiple threads, or because the actor systems are also a sort of concurrency kind of thing, right? Where you could send messages to a different actor to do or multiple different actors. So is that at the actor level?
That's the platform basically which does that. So your actor runs in a single thread synchronously,
Okay.
and it gets a message, processes, and then it sends a message essentially. And it can also get a message, send a message to someone else, wait for the response, keep processing a bit. But yeah, that's essentially how it works. And yeah, you've got actor systems in. I mean, you use the abstraction of an actor also in low-level languages like C++ for game programming or stuff like that. But then that's not the level of abstraction where we're using it. We're using it to kind of structure your code in terms of its units or its
Okay.
right. And yeah, that's where we use the actor abstraction essentially. Yeah.
Cool.
Yeah, and it compiles to WebAssembly. So that's the other. So that's the reason we have a new language. Really, is that it compiles to WebAssembly with
Oh, okay.
no JavaScript stops needed, right? Because you can say, oh yeah, I mean C# compiles to WebAssembly. There's the Blazor stuff and all that. I don't know if you know about that, but all of that usually involves compiling C# to WebAssembly and then also 500 kilobytes of JavaScript. But our platform does only evaluates WebAssembly, so there's no browser there. So
Okay. Cool.
I'm sure, right? So,
Okay, that's actually pretty interesting. Are we going to have a Motoku backend for PureScript? Asks Paloo.
I don't know if that's a sensible target.
I mean, we have an Erlang, so why not?
Yeah, I mean, it would certainly be possible. That wouldn't be that probably wouldn't be all that hard actually. Well, yeah, it probably would be that hard. That would probably actually work. Yeah, I don't know if you do that. What I have certainly done is built a little bit of a backend in Motoku on the platform we're building, and then put a PureScript front end in front of that. That works just fine.
Cool.
Yeah.
Yeah, like the actor-based systems are pretty interesting, right? Because it's very hard to replicate something like that in a different language. And if you put a lot of effort and money into it, like Scala with Akka or Akka.net for the .NET world, then you can kind of get something like that. But it's something that's very costly. Because, for example, at my current job, I do Scala, and the main reason I couldn't even dream of changing it with anything else is Akka, right? You can't like Haskell doesn't have something like that, and there's no way you can build something like that from scratch in a reasonable amount of time. Like it's not cheap to build something like Akka for Haskell, and to be able to like scale horizontally like with this sort of idea, right? Whereas actually it's pretty interesting. Like for example, Beam, or not Beam, I'm being crazy. Like the Erlang ecosystem has this new language Hamler, which looks like Haskell, which is basically Haskell on the. Yeah.
Calling it a new language is also kind of, I mean, it's just
Yeah.
the PureScript compiler, right? It's just a fork of the PureScript compiler, and with a couple of syntax things changed so they look like Haskell.
Oh, really? Hamler is a PureScript fork?
It's a fork of the PureScript compiler.
I
Yes.
actually had no idea about that. Really?
Yes, it is. It's a
Okay.
fork of the PureScript 0.13.8, and then they added the bunch of Haskell syntax back in.
Oh, so is that basically the related in any way to the like PureScript Erlang backend, or?
No, it's not.
Oh, so it's something else.
That's
Okay.
the thing that's kind of weird, because it also just compiles the core FN and then does stuff from there, which
Okay.
is exactly what the Erlang backend does. And it's really just, I mean, you could just use PureScript Erlang, or you could make a fork of PureScript that makes the syntax slightly different so it looks like Haskell again. And then now you can't use any of the PureScript ecosystem. But
Okay, that's weird. Yeah, because they don't have anything, right? They don't have any ecosystem. They have to build everything from scratch, right? Which is a weird choice. Yeah, I actually had no idea. So I actually thought that they started from scratch, or that they started from Haskell, and it was too hard to port Haskell libraries, because that's a bit harder, right? But okay, that's awkward. That's a weird choice. Okay.
Agreed.
Okay, interesting. Yeah. So wait, I think this is Bolt from Slack, who's asking, who's saying that Motoku looks cool, and whether we could see an example. Are there some examples on some website somewhere, or?
Sure. Yeah. I mean, if you go to sdk.definity.org,
Let's try to do
find
that.
a couple examples there.
Let's try to swap scenes and see if this scene works. Cool. So can you repeat that URL?
So SDK.
Okay.
Dot Definity. So DFINITY.
Okay. That's
org.
Let's see if I managed to type this right. Okay, cool. So where should I go to see examples?
So see on the left, there's the Motoku language guide. Probably start there.
Okay.
And maybe basic concepts and terms. That's probably got a few programs in there. And so it's a language with curly braces, and the idea there is that it's supposed to look familiar to JavaScript developers.
Okay. Okay. So it's kind of like, okay, so like effects are units, right? You kind of don't
There's no effect. There's no monads yet. Nothing like that. But I mean, there is async, right? So async is its own thing.
Also, async is kind of like a block where you can do asynchronous effects, or
similar to, you've got async await syntax basically. If you, I mean, I think you've done C# before, right? So
yeah.
May have that probably. I don't know if there's I don't know if there's an interesting example program here.
I mean, this is it. Okay, apparently not too complicated. Nothing too complicated here.
I mean, if we, you know what? I've got a very simple small program for you. If you want to go to my GitHub and then check out my repos, there's one which is called IC101.
IC101. Oh, I think it was literally the second thing here. So I think I glanced something with my, this one, I guess.
Yeah, and GitHub it recognizes MO files as Modelica, but it's not that. And then you pick up the upper one, yeah, and that's got a Motoku file in it.
Okay. Oh, so
And
it's
so there's the
okay.
tiny actor exposes a simple function which takes a name and returns a greeting containing that name.
Okay. Cool. Yeah, that's yeah. I mean, it looks pretty clean, like the syntax, not too heavy. Okay, interesting. Cool. So let's go back for a bit and see what else. Sorry about. I keep clicking the wrong thing. Wait, did we lost? I'm not hearing you anymore, Christoph. Did you mute by accident or what happened? Because I'm not hearing you, Christoph. Or maybe I did something. I don't think I did. Let me try, because I'm not sure if he's hearing me either. Okay, he can't hear me either. Okay, I can hear music. Yeah, he's muted for me as well. Let's try to...
Hello, can you hear me now?
Yeah, I can hear you now. Do you mind resharing your cam?
Yeah, let me do that real quick. Discord.
Cool.
Does it work?
Yep, we're back.
We're back. Okay.
Cool. So what were we talking about? Sorry, I think I saw you were talking. I tried to message you as soon as possible.
Mm-hmm. Yeah, I mean, I was primarily saying I can't hear you anymore.
Oh, okay, cool.
But yeah, that was the like I don't know where I set out, but that was like the minimal Motoku example you could use to get started if you were into that. And then yeah, so if people are interested in that, feel free to check it out.
Okay, so let's see. Well, I guess we could get into the like your type checker / type inference like talks and presentations and so on, right? So
Sure.
how did that start, right? Because you've done quite a few of those, right? It's kind of like a series.
Exactly, yeah, and I've kind of kept on refining it and making it better. Yeah, so I mean, where that started really is my bachelor's thesis. So I had no idea of type checking before that, and then Phil really taught me just enough theory and told me to what book to buy and what to read. And then that's where I learned how to do type inference essentially in the style in which it is done in ML compilers really. And then I learned a bit more on that. So that's algorithm W. I don't know if you've heard about that one. That's basically that's the thing that ML uses, standard ML, and it's basically just unification as a solving algorithm. And then when you get into a language like PureScript, which is a little more complicated and undecidable, like you can't infer the type of everything.
Yep.
Then you get into bidirectional type checking usually.
Okay. I mean, luckily, most programmers will add a lot of type declarations to everything, and then it makes the compiler's job doable, right? It ends up kind of working, but yeah.
Right. And I mean, and bidirectional type checking is exactly that. Is like taking advantage of these type annotations where there's two directions. There's the one inference, and then there's check. So the check inference is when you have a type annotation and you're just checking against that type, rather than trying to infer everything from zero.
Okay.
From nothing, right?
Interesting.
And yeah, a lot of the direct dependently type languages will also use these kinds of type systems.
Cool.
And so yeah, I really got into. So I got started on the type checker stuff when I did the bachelor's thesis for typed holds, and I felt like there was a lack of resources explaining that, because it's not really that hard. But you need to find I really needed to find Phil to explain to me how it worked, because there was no resource I could have really just picked up and went with.
Yeah, I mean, there are some academic resources, but they're not that easy to digest, right? If you haven't done it before.
Yeah, they usually expect lots of background before and then they approach it from, I don't know, some extreme angle, and then derive everything from there. But that's usually not a position you've already, like, you're coming from.
Yeah.
And so I built, like, I set out to make this talk presentation, which is like type entrance for the, I don't know, working programmer essentially. So you know how to program, you've kind of written a parser before maybe, so now you've got an AST. How do you type check that?
Cool.
And so yeah, so the first version I gave of that talk is I gave at Functional BY, which is a conference in Belarus, in Belarus, sorry. And that was recorded and it's on YouTube, and I think it was received pretty well. I think Palu, for example, actually learned how to do type checking by watching that video, stopping and rewinding a lot, because I thought I had an hour and 15 minutes, and then I ended up having 35 minutes, which meant that I had to go really quickly, and I had to, yeah, and I learned that like 2 days before, so I ended up practicing in front of the mirror a lot on how to make that quicker and cut it down. But it worked out quite well, I think.
Cool.
And
like the first version were in Haskell, right? You used Haskell as the language.
Exactly, it was Haskell. Yes, because I had done it in Haskell now, because for my bachelor's thesis, essentially, I had written the program once, so I kind of knew where to put it and like where things
went. So it was mostly because you are very familiar with the language, and you've written it in Haskell before, and you thought that the language gives you enough, like gives you a lot of features to write it simply, right? Which is totally true, right?
I didn't use Haskell features really, or like not lots of them. It uses ADT, it uses pattern matching, and it uses recursion. That's really the few things you need. And then there's also a state mode in there somewhere, but if you write the program in an imperative language, that's just a counter you keep increasing. So that's not really...
Sure, but then if you also want to do okay, if you already have everything, that's fine, right? But if you want to build a real example, you want to do some parsing and show that, add that there, right, to parse the AST rather than just type it out manually. So then Haskell or like PureScript or some language that already has parsers can definitely help, right?
Oh yeah, and exactly, and because I already knew how to write a parser in Haskell, I just did that. Yeah.
Yep, that totally makes sense. Okay, so did you use any other language? Because I know the latest versions were using Kotlin, and you've mentioned that earlier, right? So were there other versions in between?
Yes, there was. I did the thing. So I did the same. So the version that I gave as a talk had all the code in slides, and I kept clicking forward, and like more code would appear and that kind of stuff. And then I gave it again at the BusConf, which is like an open space style conference. I gave a version of it where I wrote the type checker in Rust as a live coding exercise.
Oh, cool.
And so that took a lot longer because now I'm actually writing the code. But yeah, I wrote that in Rust at the time because I gave out a poll. I asked the participants, what language would you want to write it in? And I said, I don't know, I think I said Haskell, Rust, or Kotlin, and people were like, okay, let's do it in Rust, because maybe they had seen too much Haskell at the conference before or something.
Cool.
And so we did in Rust. But really, I don't think Rust is a great language for doing it as a talk or explaining it, because memory management is really not something you want to deal with when you're explaining an algorithm as like...
You don't get into those sort of details because they're not relevant to the subject.
Exactly, yeah. They get in the way. You can do that afterwards. Like the third time around you write it, you can think about how to make it fast. Step one is how to understand, like how to actually make
definitely. And then there's also always the chance that somebody sees some like interesting Rust related thing there while you're doing all that, and might maybe ask a question about how do you do memory management there, and kind of like don't want to be rude and not answer, but also that's not the point of what you're trying to say, right? So
Exactly. Yes. 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 Yes.
like it's
Yes.
interesting, but not now, right?
Yes, and I mean, and it is really interesting, and it's going to get me
Mhm.
sidetracked because it's stuff that I'm actually thinking about right now, right? Or that I'm moving back and forth in my head on how to do this the best way. Yes,
Yeah.
um, exactly. And then, and after that, I did a workshop version of it,
Hmm.
where now I have a bunch of unit tests, and I have written all the stuff around it. So they're uh, what you get when you do that workshop essentially is you start out with a project that has Alexa, a parser, and an interpreter,
Hmm.
and just in the middle of the type check is missing essentially. But you can already write programs and run them. It's just that
Okay.
sometimes you get type incorrect programs and they crash at runtime.
Okay. Cool.
So that gives you an easy way to motivate why might want to add a type check in between. And then I
Okay.
have a bunch of unit tests that are like lessons essentially, and your
Hmm.
job is always to make them green essentially. And we
Okay.
go back and forth. Like I show a bit, and then I make a bunch of tests green, and then the participants do in like sessions of I don't know 10 to 15 minutes usually in pair
Hmm.
programming style. And I did that one time in person at a meetup in Cologne, and that
Hmm.
worked out very well. We were there for 3 hours, so it takes a while to write that thing. But we had, I think, 30 participants or something, and everyone stayed for the full 3 hours after work.
Cool.
So that must have been all right. And I got lots of positive feedback. And that version of the thing is written in Kotlin again because
Hmm.
I'm trying to assume as little as possible pre-existing knowledge, and that was a workshop for a conference, not conference, meetup, which is usually
Hmm.
Java-ish developers. So lots of them can just pick up Kotlin and run with it.
Hmm.
Um,
Cool.
and I did that one more time then in a remote setting this time around for the Berlin
Meet
functional
up, right?
programming meetup,
Hmm.
which opened up during Corona for more um, non-locals essentially. And
Yeah,
so we did
fully online.
another version of that there, which I think went quite well as well.
Hmm. Cool.